Welcome to Embedded. I'm Alicia White alongside Christopher White. We're going to chat with Phillip Johnston of Embedded Artistry about changes.
Hi, Phillip. Welcome back.
Hi, thanks for having me back on.
Could you tell us about yourself as if we met at an embedded systems conference?
Sure. I'm Phillip Johnston, the founder of Embedded Artistry. We are an embedded systems consulting and education firm. I've been an embedded developer for 13-ish years now, and in that time I've helped ship more than a dozen products across a number of industries, including desktop software, consumer electronics, defense, robotics, drones, you name it. My main interest is helping to bring embedded software development out of the dark ages, and currently I'm focused on doing that through a three-pronged approach of designing software for change, building testable systems, and leveraging automated software quality enforcement practices.
Where's the fourth prong of getting people to listen to you?
You know, I try not to worry about that one too much because I can't control it.
Are you ready for lightning round?
I am. This is always the most stressful part.
What was your first computer?
You know, I don't know, but it ran Windows 95.
What does that look for?
I just expected it to be older than that. What was your first programming language?
C.
When you were 5, what did you want to be when you grew up? If you can't remember when you were 5, pick any later date.
I do remember, and I wanted to be a paleontologist.
I still want to be a paleontologist.
Yeah, I think it would be quite cool.
When you were starting college, what did you want to be when you grew up?
A philosopher.
Okay, continuing on this theme, apparently. What do you want to be when you grow up now?
I guess now I'd settle for gardener.
When you were in college, how much RAM was a lot of RAM for your computer?
In college, I want to say I was in the gigabyte range. I don't remember exactly. But my first computer, I do remember my father paid, I think, $1,000 extra to get the 4 megabyte option.
Yeah. All right. Let us...
You don't want to know how much an extra 16K was for my first computer.
Yeah.
And you had to put the chips in by yourself. Like, they went in chips, into sockets. Anyway.
Yeah, I luckily missed all that.
You recently posted a blog post about how your approach to abstract interfaces has changed over the years. And then it caught my eye because you don't always think about how your design philosophies and implementation principles changes. Could you describe what you wrote?
Sure. So I guess backing up before the article, the main problems that I'm interested in solving are, related to the fact that no matter how well we think we design our software, there's always like some change that comes in, either a part changes or you got to use a new processor or some requirements change comes in. And then it's not easy to make that change. It's always a huge rewrite, it seems. And, it's not just swapping out a couple files. Suddenly I find that whatever I'm changing has touched every file in the repository, and now it's a big effort. So that inspired a lot of my interest in, how can I solve this problem? And abstract interfaces, through the work of David Parnas in particular, and the ideas of information hiding, were something that really struck me when I first came across it, and that I've employed with great success in my career. So I described how when I encountered abstract interfaces and actually used them in systems, I would, go through the typical exercise of, let's say I have a SPI or an I2C interface for a SPI controller or an I2C controller. By having a standard interface for that, I can swap out implementations using the same interface, and any software that relies on that interface doesn't have to change.
When you say interface for like those things, you mean like read, write, start?
Read, write, start, stop, depending on what it is, configuration may or may not be included. I think SPI configuration is probably a bit more standard than, configuring an accelerometer, where every accelerometer has different frequencies and filtering options and wake-up events and things like that.
And the POSIX open, close, read, write, octal has always been in the back of my mind as let's just standardize the interfaces to everything. Okay, but now you don't think it should be like that? I mean, that works. That works for a lot of things.
It works for a lot of things. I've done a lot of really cool stuff with it. Like nowadays, I almost always write new drivers for new components on my development machine using a Aardvark debug adapter. So I'm connected to whatever breakout board I have over USB, and I can, talk to the actual hardware. I can write my driver. I can write tests against real hardware. I can record data and play that back in automated testing. And most importantly, I can move it to my, target processor, and it's just going to work for the most part. There's always, some gotchas that might come up with memory or timing, or your implementation isn't quite correct. Things like that do still happen. But for the most part, I can easily move stuff around. So that has a lot of benefits, but there are downsides that I think come up quite a bit. One is you're always locked into a particular interface. So the goals of okay, now I can change what hardware I'm working on have been met, but I can't necessarily take that driver and use it in a totally different ecosystem or a totally different client project that's not using all of my abstractions and supporting tools and things of that nature. And so you're sort of become locked into whatever ecosystem or whatever set of interfaces you've developed for yourself. And two, and I think this part is, it's very difficult to overcome it. It's hard to create good interfaces without a lot of experience. And getting an abstract interface wrong and having a lot of different implementations and then finding out that you have to change that causes just as much cascading change to happen as, if you didn't have it in the first place. Now, I mean, that's true of whether or not an interface is abstract or not, right? Interface changes are always painful. But the scope of the interface, I think, makes it more likely that you're going to do something erroneously that you want to change later. And so, my efforts shifted after being exposed to just, randomly through a client project, coming across a driver that did something totally differently, where instead of depending on some particular SDK or particular abstract interface for a SPI controller, this driver just defined one function that you had to implement in your own application to handle the SPI transactions. And that was just a totally novel approach to me. And, it addresses some of these concerns of, well, I just have one function. So the odds that you're going to define one function correctly that, in such a way that the interface you create is going to be able to meet the needs of that component within your system and to support multiple implementations, that's going to be, a lot easier to get correct than if you're going to define a fully fledged SPI controller interface with a bunch of different knobs. And even though those knobs do provide benefits to you, like being able to control a device in a standard way, you're still locked in. Whereas if I have one function to define in my driver implementation, I can use it with an Arduino SDK. I can use it with my own framework. I can run it on Zephyr, you name it, right? Implementing one function is easy. Implementing a full interface always takes, it takes a lot more time.
Okay. We've been pretty abstract here, and I think I need to get to some concrete examples.
Great.
And what I'm thinking of as you talk is there's a inertial navigation library that does fancy things, and it uses a particular IMU, and it runs library code on my processor in order to do this.
So I understand, library code on your processor to speak to the device?
Yeah, so they have a library that implements, say, the Kalman filter.
Right.
And I'm not allowed to really look in there.
Right.
And what they want me to do is be able to provide the code that talks to the actual unit.
Okay.
Because they know how to do all of the registers on the unit, but they don't really know whether I'm using SPI on a Cypress or SPI on a PIC.
Gotcha.
Okay. So I have this library that wants to be able to send and receive messages to the device that it was written for. And this is kind of a complicated example, but there's a lot of if you think about the libraries, that means that you have something separate and something that you do want to think about changing for the future. And I can see how in the past, I would have expected that library to ask me to implement a driver that had an init, a re-init, maybe a reset, a read and a write that would do lengths. But actually, in fact, recently when I had this entire problem, it had me implement spy transfer, read write. And it didn't want any other functions. It didn't want to know about inits. It didn't care about resets. That was all up to me. What it wanted was to be able to talk to the unit. And so it was only one function I had to implement. Is that what you mean, or am I on a different path?
That is exactly what I mean. Exact same example.
That's when you have control over something somebody else is going to implement the lower levels for. In this example, I would be the library developer, or in a different example, I would be the GUI developer wanting to talk to an LCD, but not wanting to have to deal with whether it's hooked up in SPI or parallel. I just want to send things.
Mm-hmm.
Is this abstracting the hardware, or is it abstracting the software, or does it matter?
I don't think it matters. I think that we can view it as a general technique that we can use in our systems. So, one tool in the toolbox is the full abstract interface, and that's still useful. Like, having a standard way to talk to a device from your application code that allows you to swap out the device you're talking to, or it could be anything. It could be a particular library. It could be a database, whatever. But having some abstraction on top of that so you can swap out an implementation without impacting other code, that's great, and that's one tool. On the other hand, I think another tool that we should have in our kits that we should be able to employ when we need it is to realize that, okay, we don't need a full interface for this problem. I really just need one function, or there's one particular detail that I can't manage in this library that's going to change when some aspect of the system changes. That might be what implementation I'm using, or a specific configuration, or maybe some applications are threaded and some aren't, and I need to have a way to defer that kind of decision to the application. So I think there are a number of ways that this can really benefit our system design that aren't just decoupling from hardware.
The old way of implementing abstract interfaces, in your blog post, it mentioned function pointers. And so the library in this case would say you have to implement a structure that includes these functions, the read and init and all of those functions, and you do the function pointers. That was an extremely TI thing. I mean, they did that, I would say to excess, because sometimes there were 20 or 30 functions you needed to put in. Where did you pick it up? Please don't say my book.
I didn't pick it up from your book.
Yes.
I must have been exposed to that idea. It was either at Apple. It must have been at Apple. I was working on the diagnostic firmware team, and I think they managed a lot of things that way. Like the code was based on the EFI framework, and we definitely had some function pointer structs and abstract interface ideas in there.
That's funny you mentioned Apple, because this whole idea of having a framework that does something, but it needs help, and the help can vary. So give me the one function that will help me, is very straight out of like the UI frameworks, where there are delegates and things, these callback functions that maybe something draws, a table for you, but it needs to know how to draw each individual cell. So it can do all the machinery and lay things out, but it doesn't know what you want to do for drawing the cell. So here's this function, draw a cell that you have to fill in, and then it takes care of that low-level part of the drawing based on what you want it to do, it seems very similar to me of, okay, here's this complicated driver that maybe has lots of high-level intelligence, but really it also needs to know how to talk to its device, and please tell us how to talk to the device, and that's all I need.
That's interesting. That's the word we should be using.
What?
This function that we need to implement for our API or our library, this one function, or even the 5 functions in a driver that they want us to implement, those are delegates. Those are things that they have said, we need you to implement this. It's not a delegate like it is in Swift, but it is a concept. And I think for many things in C, we don't always have the word because we don't have the concept or
the design pattern.
I guess, but is the word delegate and how it works a design pattern?
No,
I guess maybe.
I don't know. I don't remember.
Anyway, so delegates. And then I feel like, what about callbacks? Those aren't delegates.
They can be. It depends on their function.
That's another thing I see with some library implementations is that they don't want to tell me what's happening inside, but if they need to, like a UI library needing to get images from somewhere, it doesn't want to know where it's getting images from. It just wants to call a callback that says, give me more data.
Yeah. Can you tell we've been working on UI slightly?
I can tell.
Okay, so do you use the word delegate in your blog post?
So I'm going to get to that, but I want to address another point that you had made earlier and then come back to this.
Okay.
So when you said the TI does it to the extreme and there's, like sometimes there's 20 something interfaces you have to implement, I think that's an anti-pattern, right? Because you don't want to have to implement 20 interfaces to get something up and running. Like that's a pretty significant time cost where essentially you're going to take whatever implementation you already have and now I'm going to shim it to this TI implementation interface expectation. Like being able to do that on a smaller set of interfaces is much easier, right? You're going to be able to react and change and swap things out and get things running much easier if you have a smaller set of things to work with. So I think that TI example is a good indicator of like where this kind of abstraction approach can go wrong.
It is.
Or not wrong, but difficult, perhaps.
It's like they have a whole operating system and they do it with function pointers so you can replace things. Mm-hmm. And they do give it all to you for the default version, but you can change every little thing, which means that you have to think about changing every little thing, which I never really want to even think about it. Because then if I do it, I've done it wrong, but if I don't do it, maybe I'm doing that wrong. Anyway, back to you, Philip.
And right, so back to the delegate question. I don't call it delegates. I think it's a perfectly suitable word. I view it as the template method pattern, and I think that's just, I was exposed to that before I was exposed to the concept of a delegate, but I think they serve the same thing. And so that pattern comes from, as far as I know, the classical Gang of Four design patterns book.
Yeah, okay.
And basically it says that you have a function, the template method, that has some steps that are controlled by that function and some steps which are deferred to the user application that are either, requiring your function requires the user application to implement it, or it provides an optional hook, which I think a callback applies in the same conceptual idea, that allows an application to override or, modify slightly how an implementation is doing things. And with embedded systems in particular, I think that just that idea of like, okay, we can have a function. I'm going to have some steps that I'm going to defer to the user that they have to implement, like a SPY transfer function for your particular platform. And some things that, you can override if my particular default implementation doesn't meet the needs of the situation. I think that's a powerful tool because we do care about performance in the embedded world, perhaps more than other software systems with multiple gigahertz processors and gigabytes of RAM have to care. And so I think it's probably more common for us to need to tune the implementation, although I'm sure, now that I've said that, 1,000 counterexamples can be thrown my way, showing how I don't know what I'm talking about. So
it's funny, the template method. I was trying to remember why I don't think about that one. And it's partially because it says very clearly that it is based on inheritance. And so as soon as it says that, I'm like, well, let's just check that one out. It's not like I can't use inheritance. It's just that I don't have a language that makes it easy, so meh. But you're right. That is what it is. You're taking pieces out and allowing their implementation to be done elsewhere.
I think this is one of the trickier points of design patterns, right? It's easy to look at a pattern and say, oh, this doesn't apply to me because of whatever thing. And yet there are still going to be aspects about a pattern that are crucial. Like, we could debate, and there are very good points to be made on either side about whether or not inheritance is really key to the template method or not. In my interpretation, I just kind of ignore inheritance altogether. Like, I think you could achieve a template method through any number of ways that don't rely on inheritance, although that was the classical application of the pattern.
The thing with design patterns is that there are a billion of them. And at some point, I can't sit down at my desk and say, okay, today I need to fix this bug or make this LED blink at some frequency. Which pattern should I use? It's not that it's metacognition, but there is the chance of having design where you don't really need it.
The best places I've encountered patterns and been able to use them is when the thing I'm working with enforces them. Coming back to Apple, they're very opinionated about the way the language is set up and the way the frameworks work, and you will use these patterns or you will be unhappy with your life. And that's the best way I've learned about them is like, well, this is what's happening on this project. These are the patterns. Certainly, I've never come into something and said, well, time to flip through this book and see if I want an adapter for this. Or, I don't know how to bridge that gap unless you're doing a lot of whiteboard design and trying to be very abstract.
Well, I guess for me, I agree. I don't sit down and approach a problem and think about what patterns apply. I guess if I'm trying to analyze my own process, which is always fraught with error. But I think when I'm reading about patterns or I encounter a new pattern, in the back of my mind, I have a general set of problems that I'm sort of always dealing with, or, something that I'm struggling with at the moment, or something I'm unsatisfied with how I implemented it. And, when I'm reading patterns, often I'm, in the back of my mind, I'm running through my collected set of problems and seeing how this pattern might apply to this particular situation. And that can lead to interesting results, or, I might run an experiment and see how it works. And then having implemented something, it's more likely to be fresh in my mind, or I might like a particular thing in a given pattern and realize I can apply that one little piece to some problem I'm dealing with. So I think for me, that's how it usually ends up working out in practice.
And there's definitely a couple of them that I tend to reach for because I've learned to use them and, okay, this is the way I do things. Like you said, there's a billion of them, but there's like 3 or 4 that are sort of key core concepts that whether or not you're using them, a lot of times people will be using.
Yeah, but sometimes I find them confusing because there's publish, subscribe. That's something I'm very familiar with. I've worked with the robot operating system. It's all about that. If you ever want to see publish and subscribe on a large scale, go there. But then when somebody said something about the observer pattern, I was like, which one is that? And it's pub sub, but they have different names. Mm-hmm. Mm-hmm. And if I use the state pattern, which is a state machine, which I use all the time, do I have to call it a state pattern?
Only if the people who are reading it care. I don't think there's any, board of certification saying, well, I'm sorry, you called this something wrong, so your code doesn't work.
But like Phillip was saying that he comes across it and then he thinks about it for a while in the future. How do you come across them?
I'm always reading. I think that's just it's been a perennial thing in my life that's, ongoing. I'm probably reading something an hour or 2 a day, whenever I get my free time. And so it's not always technical. It's, it's not always a book, but whenever I encounter ideas that are interesting, I I either play with them in my mind, or I have some project I can apply it to see if it solves my problem, or I just make some notes and start coalescing the ideas over time, especially if I keep running into a given situation or a given pattern, and I notice that my notes are building some momentum and actually like sufficient size. Is probably something I should pay attention to.
What kind of books do you read to randomly come across software patterns?
Well, there's great design pattern books. I mean, design patterns, the classic Gang of Four books is one. Your book has design patterns. There's
the head first one. If you're new to design patterns, I've really liked the head first one. It's written in Java, but it makes things physical in many ways. That is what I need to make things work in my head.
I'll have to look for that one. I don't think I've heard of that. There's the Bruce Powell's book. I can't think of the name right now, but he has it's something along the lines of like embedded software patterns in C, or, we can find that book title and link it in the show notes so we're not misleading people. But that's another one. And papers. I mean, there's like a whole conference on the pattern language of programming, something like that, where people are submitting new patterns. And, I occasionally like look through that to try to find, anything that might be relevant in the embedded space.
You actually go out and look at academic papers for design pattern conferences.
Are you research shaming him?
I don't mean to be. I guess I'm research shaming me.
I read a lot of academic papers. I don't necessarily seek out papers about patterns. That's just one that's in my radar. But I found a lot of really valuable ideas from papers. Like one of my favorite papers of all time is a David Parnas paper from 1978. And again, I don't remember the title off my head, so we can link that one too. But Parnas describes like the exact same situation that I deal with all the time, and embedded software being difficult to change, and so there's ideas that are still to be discovered or not well socialized, because I don't think a lot of embedded software professionals are reading the software academic literature to look for new ideas. Another paper I like comes from the 90s. It's in a similar, this one's called Towards a New Model of Abstraction and Software Engineering, or something like that. I should have practiced all these titles beforehand. I didn't. But that one is related to Joel Spolsky's famous law of leaky abstractions, where the author of this paper notes that, we have these ideas of what abstraction provides us. Like, it supports change. We don't have to worry about the implementation, the general things of that nature. And then he, like Spolsky, points out that no, generally when something goes wrong with an abstraction, it like is related to the implementation causing some performance problem that impacts your system. And the general recourse to that, which I think we're all familiar with if you're using an open source project that doesn't quite work the way you want, is now you have to take over the implementation yourself, right? So you went from having this nice abstraction or library or, driver or whatever you got from someone else, and it just doesn't work well for you. So now you have to re-implement it. And nobody's going to be surprised by that, right? But in the ideal world, you'd be able to tune something about that implementation without having to take on full ownership of it or write your own implementation or, whatever other recourse you're stuck with. And so he talks about this idea of, well, don't just make one interface for your components. Why don't you make two interfaces? You have the traditional interface that, we use to interact with a component that will design according to information hiding principles. So we're hiding the implementation, and we can swap out implementations if we need, and our application code can remain unchanged. Like, we can still have all that. We just also need a second interface that lets us tune the parts about the implementation that we need to change. And, when you think about that problem, like, okay, this is a paper that was written in the 90s. I've never heard anybody tell me that I should think about all of my components as having two interfaces. One which is used to, make my program work, and the other which is actually used to change how it behaves if I need to. And so there are a lot of ideas like that have really impacted how I approach design or solve problems, or just, I have new tools in my mental toolkit to reach for whenever I notice I'm in a particular situation. And so I do, I don't spend all my time in the literature, but I do try to at least read the famous papers and, the papers those reference, or papers that reference those. I do a lot of bibliography diving to find what I should read next.
It's funny because I feel like so much of not computer science, but professional software engineering has been this struggle to find ways to stop doing things over and over again. But there's this tension between making things abstract so that we can reuse code and be portable, and having things be well suited for the platform we're running on. And it keeps going back and forth where, this cross-platform library is very popular. But it doesn't work as well as developing native. So now everybody has a native team for every mobile, device, then writes a different app. And then, it goes back, and now we're all using the same thing. I just feel like this has been this constant struggle between how do we reuse code and, we should just give up because it ends up not working that well. And that's not necessarily towards the thing we're talking about right now, which doesn't really have that problem. It's a very focused thing. But I do feel like that's been a struggle that hasn't been resolved and kind of goes back and forth. And I don't know if it's resolvable in a general sense. But it just seems like, why are we writing all these things over and over again? Why, when I start a new client project, am I writing some of the same code that I did at the previous client project? There's ownership issues, of course, but it just feels like we should be building on the shoulders of the previous code, and we don't get to do that much.
I have a good story about this. It's from ClassPert. When people were turning in their final projects, one person turned in a final project that was, pretty good, but there was one section of code that was really good. Like really nice. And I asked them to be sure to check the licenses and to document that in their final reports. And so it was documented in the final report, but in the code, it wasn't. And I was about to write a nice long complimentary paragraph about how this code was super clean and it was good and it looked like he had tested it very well. And then I thought about it for a little while, and I went and I looked and I noticed the license, and it turned out it was written by Phillip. It was his circular buffer library.
So you're just saying I should take everything from Phillip?
I believe so. He's got this whole embedded virtual machine.
Problem solved. And maybe, that may be the solution, partially, not to take everything from Phillip, but to have a better...
Please don't, that's a lot of pressure.
Have a better awareness of what's already out there, or go looking for things, not in a Stack Overflow sort of search way, but at the start of a project, is there something that's already been done that does what I want, that is licensable, instead of saying, time to implement a state machine framework for these people, and a time to implement a logger for these people.
The chip I'm using now has 97 application notes for how to do bootloading. And each one has something just a little different, whether you're doing it from serial or Bluetooth.
Sometimes your efforts...
secure or very secure. And digging through this information has been horrible. And I knew what change I needed to make, like the first day, but I couldn't figure out how to prove it to myself. It took me like a week of reading their documents and trying out their stupid bootloaders before I got back to the original decision to just change this thing that the compiler said I shouldn't.
Now, I might argue that could be worth a week's worth of research time for a bootloader, right? You want to make sure that thing is actually working correctly, and that thing the compiler is telling you not to do isn't really a problem.
Yeah, don't push on that. It's already been a week. They're going to want results soon.
Yeah, there is that. Well, and I think this general idea...
I've worked in the private sector. They want results.
And I think this general idea goes back to a theme that has come up over and over again in our conversations, which is like, maybe you can take 2 weeks to research things instead of starting immediately. Now, I know that no team in the world wants to hear that, and I've never convinced any startups I've worked with ever that 2 weeks is an acceptable period of research and prototyping and design to figure out what you're actually going to do. But, I think it is certainly worth it to figure out what's out there and what components can I reuse that exist.
I understand the reading for an hour a day, but how do you choose whether you're reading academic software papers or working on a personal project with an Arduino?
I let my interest drive what I'm spending time on more than anything, at least in the learning regard. Obviously I have constraints from the work I'm trying to get done too. And sometimes that drives my reading too. If I'm need to figure something out for a particular project, I will try to focus on things that are relevant to that. So it's a little bit of a choose your own adventure and a little bit of the needs drive the situation.
Where do you look?
For papers or just in general?
Yeah.
Papers, again, I do a lot of bibliography diving. So in any paper I come across that I like, I look for references that seem interesting, and then I'll usually go to the ACM or IEEE digital libraries to see if the papers are there. Sometimes I Google stuff. There was, I can't remember the name, but there's a list of famous software engineering papers or like award-winning software engineering papers by year for a particular journal. I'll look for collections like that. In books, if there's papers mentioned in a book that seem interesting, I tend to pick those up. So usually my reading is guided by other reading more than it is from me just going out and randomly trying to pick things.
All right. Well, I'm not going to feel bad that I would rather do projects.
I think that's okay.
I don't always get as much software education as I want, but if it's a matter of staying motivated, having to do something is more pleasing to me.
We just have people come tell us things about software.
Well, that is true.
Yeah, you have the come to me model. That's a pretty good one. Tell me all the interesting things and I'll pick and choose what I'm going to focus on.
I read Philip's blog post and I learned a ton. He's already filtered all that research into a blog post. So
there is that. That is true. A lot of research went into that over the years.
One of the things that your blog post says is that your opinion has changed. And how you describe it, it totally makes sense. But that sort of change is hard for us. I mean, we get stuck in, I still hear people argue about VI versus Emacs. Nobody cares.
Right.
Yeah, why aren't you using VS Code? You can have VI and Emacs in one beautiful package.
What other changes have you identified for yourself? I mean, that's hard to even identify, but have you identified other ones?
Tying that point back into what Chris mentioned earlier, I originally approached a lot of my design and development efforts from the idea of like, okay, I've written literally the same IMU driver for 6 clients. And the reason I'm doing that is because of IP reasons, and whatever implementation is out there doesn't meet the needs for whatever I have to do. And, and that kind of thing happened over and over again. I can't tell you the number of TI gas gauge drivers I've written over the years, or it's just over and over again.
See, the thing is, this is resonating because for a while I was a very specialist for some reason in doing optical coherence tomography, imaging front-end software, and driver software for medical startups.
I don't know what any of that means.
It doesn't matter, okay. But it was complicated, and I had to do UIs and graphics and talk to specific weird hardware. And for some reason, after doing it once, all these clients came out of the woodwork and said, I just kept getting referred to one to another, and I kept writing the same exact software package. I think I did it 4 times. And I got, by the 4th time, it was autopilot. I just wrote the same code. I wasn't stealing. There was no IP, but I'd done it so many times that I was just autopilot. Okay, well, here's this data acquisition class, and here's this UI thing, and here's how I'm going to set this up, and type. But yes, I mean, so does it matter? I mean, by the time you've done it 6 times, it's pretty easy, right?
Pretty easy. But, it's still like, it's not how I want to be spending my valuable working time, right? It's not satisfying to rewrite the same thing over and over again, practically from memory. And, and part of the appeal, like you start thinking about, okay, well, I could have a standard offering where I've already got all this stuff in place, and think of how fast it's going to be for my clients to actually, make this work really quickly. I can get them set up. They're going to have all the drivers they need. If they need a new one, it's like, okay, it'll take me a couple days to bring it up and it's going to work fine. It's like all the machinery to support it's already there. Great. It's going to be great. We're going to live in a perfect world. Everybody's going to be happy. And that just never, the goals of reusability across products and portability across systems, it didn't play out in the way that I envisioned it would. A lot of times clients didn't want that. They, regardless of the benefits that would come, they didn't want to pay a licensing cost, or they didn't even want to just not own all of the IP, right? They'd rather have you re-implement it for them even in a worse way, just to own the IP outright. So there are a lot of other concerns like that end up, taking precedence over some of the engineering ideals. And I really had to change my views on what was the real value of portability and reusability, at least in the embedded system space. And for instance, a lot of I don't focus on portability and reusability as a goal anymore. I'm more interested in how can I use these same things that would enable reusability and would enable portability to just make it easier to change the product I'm working on in response to changes in requirements or changes in the hardware availability, or changes in, like, you found out one implementation for whatever library you're using isn't suitable and you need to have another one now. So the same ideas have been sort of shifted to a different goal, but I'm sort of heartbroken now with the fact that my reusability and portability dreams just didn't play out when I had a chance to actually make that happen.
Have we switched to talking about the embedded virtual machine?
We can. That was the project. That was
okay. That was what I was wondering.
Portability and reusability project. Yep.
Tell me about this embedded virtual machine.
Well, nowadays I would describe it as a thesis on how to build software, or how you could build software if you wanted to apply these techniques in practice. And so the idea there was I would have a set of design patterns built in that you could employ to make it easier to set up portable applications or easily changed applications, supplying like a standard set of driver interfaces and ways to keep your application code decoupled from specific hardware, and just reusable machinery that comes up again and again, like a subsystem for managing different power states in your system, or a logging implementation, things like that. And the goal was, again, I could license this to clients and bring up their system quickly. Like, it would be easily supported. We could make changes very, very fast. If they needed new hardware, it would be easy to add new hardware or even outsource some components of that. And other benefits come out, like, it was built with full static analysis tool support had like 3 or 4 static analysis tools running. Everything was analyzed. It worked with multiple compilers. And I think my favorite feature was, with the way it was designed, you could supply an alternate, what you might call platform definition. So what is my application running on in terms of OS and hardware? And you could have an application running on your development machine, like a simulator for whatever you're building, and most of the code could be common across your simulator application and the application running on the target. And all these goals are achievable, but like I mentioned, nobody was interested in licensing it or even using it, for a number of reasons that I think are totally understandable now, which is, one, not owning the IP, and I think 2, like, it really ended up being an expert system where, well, I guess there's 3, but 2, it ended up being an expert system where, like, you had to know C++ pretty well and know the full framework to really take advantage of it. So for that reason, you end up with vendor lock-in, where I'm the vendor maintaining the thing, and your people can't necessarily maintain the lower layers just due to lack of knowledge, or you don't want them to invest their time in that way. And so that was a pretty big eye opener for me, and sort of the impetus for me changing some of my ideas.
So you made a system that was everything Christopher wanted with reusability, but then found out you really do have to rewrite everything.
Because that's what people want, yeah.
But not just
for real reasons, you know?
For real reasons, yeah.
And I'm very sympathetic to the vendor lock-in because, you know, it's hard when part of the reason that I was working on such a project is because I don't want to be locked into a vendor to then become that vendor, like being accused of vendor locked-in.
Don't so many clients aren't they locked in anyway? Everybody's locked into some frame, you know. Oh, I got to have a file system. Nobody's going to write their own file system, so they go buy a file system. Nobody's going to buy their own UI, write their own UI library. I've seen it, but nobody should write their own UI library. You know, people go buy those. So is that a real concern, or is it more they don't want to be locked into things that they feel like are the core of their product?
You know, I think it's a complicated answer, but that's a reasonable hypothesis.
Yeah. I wasn't expecting, you know, I'm expecting speculation, but it just seems weird to me. But
well, it's, you know,
there's many choices that are weird to me. So.
Agreed. I mean, yeah, the same clients are happy to have their, you know, their software layer directly interact with their processor SDK, right? Yes. And so now you're locked into a particular processor vendor. So, you know, I'm not saying from the client's perspective that it makes sense, but I'm saying that I do understand the accusation of vendor lock-in, even if, you know, regardless of any other things that might happen that might make that claim dubious. You know, I think it is true that you're locked in a system like I built, because going back to the full-fledged abstract interface conversation, you know, you can't use one part of the system without another part of the system because you're dependent on specific interfaces. So you now get the problem of like, okay, well, I can't just pull out this particular thing I want to use because now I have to pull out this interface, which is dependent on these types that are in this place. And great, you have a modular framework for yourself. And I mean, this kind of thing, like inside of one company, certainly has benefits. But for me, where I'm developing software that for multiple people, it becomes more problematic if there's not a way to just take the pieces that they want and leave the rest, especially when that comes with the cost of complexity that may make you not want to take the full system on. I think of, you know, Miro Samek's QP framework. I'm a huge fan of the QP framework, and I just can't tell you the number of times that I've heard people say, I like it, I just can't convince anyone on my team to use it, so we just rewrote everything ourselves. You know, so I do think there's a complexity argument to it, and like, I just can't take the pieces I need argument to it that impact everything.
And what's so sad is most of the things we're talking about are infrastructure. They're not the special thing about anyone's product, right? Nobody on their marketing sheet says, now with special in-house designed state machine.
And that's a key point. And I think that was something I emphasized in my own marketing or attempts to convince people to use this was like, you know, the part of your project that makes you money is not the drivers or the file system or the logging library or how your code boots or, you know, supporting over-the-air updates. That's not key to your business model, right? You have a product that's going to do something unique that provides value to your customers. And like, that's what you should be focusing on. And all the rest should be secondary, right? It should be, you know, whatever I can get off the shelf or however I can invest the least amount of time in it. Over the air updates being a bad example with that particular point, but.
Well, yeah. I mean, TI does it for you, sort of.
The lock-in and the tools and the framework. I think about Greining's TDD, test-driven development for embedded systems, is based on CPPU test. And I want to do more test-driven development, but CPPU test is horrible. Breaking news. I mean, I'm sure once you have it working and set up, it's acceptable, but that step, it's just no fun. And I did it for one client, and afterwards I was like, no, never again. I don't want to set this up. It's just, and so I get where you're going with this. And it is a complexity thing. It's a complexity and flexibility. It's very complex because it's very flexible, But
no actual product team often needs that level of flexibility.
right. The only reason you need that level of flexibility is because you're trying to support everything at once.
Or you have dreams about platform development where you're going to make 8 products on something and port them to different chips, which sometimes comes true.
Oh, at Leapfrog, we had just had that part locked in. The only thing we had to do were the state machines and the behaviors. And we did not mess around with how it outputs audio.
And the frog voices. You had to change the frog voices.
Well, yes, but that was a matter of putting the voices into the memory. I didn't have to worry about once they were in the memory. You have to get the frogs to
talk, which is the hard part.
Yes, that's true. But there's the little squeaky one. That was the best one. Phillip, are you still there?
I am still here.
If so, why? When we started the show, you said that embedded artistry was a a product services, but something about
consulting and education.
It was the education thing. You used to say consulting, and now you say consulting and education. When you were here last, you were starting a program to have a members section to your blog, but that's extended. So what's going on with the education world of embedded artistry?
So we do still run our membership program, and that's doing quite well. I don't have the current country count, but I think we have representation from more than 40 countries. We just added Morocco yesterday, so that was pretty exciting. And continue to publish, members-only posts that go into, analyses of some of these papers that I read, but also technical approaches to different problems or, what you might call focus topics. Like I have a section on handling code reviews in an organization, not just code reviews, I should say code and design reviews, or, a capability maturity model for, what a device and or connected IoT device, what kind of features do you really need to have on that device to take full advantage of your connected capabilities? So there are explorations like that, but we're also working on a number of courses. The current one should be finished version 1 by the time, well, not the time this comes out, but maybe a couple weeks after this comes out, is our Designing Embedded Software for Change course. We have a couple others like using C++ without the heap. I think some people in the Embedded FM Slack group used our CMake course in the book club.
Yep.
We have a Maison course. We have a Make course. So all sorts of, I would call them in-depth courses that are targeted for professionals. So, you're a professional embedded software developer. You need to solve some particular problems in your field. Like what are what's the latest and greatest techniques that you can actually apply to your systems to achieve these goals of building a system that can be easily tested, of building at least pieces of your system that can be easily changed, of automating software quality enforcement, things like that.
You have a pretty long list. Are they self-paced or cohorts?
Right now, everything is self-paced, and it is a long list, but some of them are also in development. So there are, I would say about half the courses there are completed, and then half are in different states of development. But all of them, I have hundreds of notes for each course that, when I get the time, I organize them and release that content on a rolling basis. I would like to do cohort-based stuff, but I haven't figured out a model that works for me yet. In that, just managing the time and how to interact with people and what aspects to focus on. So that is something that I have in mind, but it's probably a couple years out.
The cohorts are fun. You get a lot more interaction, but they're also fairly exhausting.
Right.
Are you having fun doing the classes? You must be, because you're expanding them.
Having a lot of fun. Yeah. It's probably the most fun I've had in my career the past couple of years.
Do you have to give up much in the way of consulting services to make time for the education?
I do, especially now with 2 kids, but I still consult. I have 3 clients now, but it tends to be, I'm doing more advising work or helping review code or, someone comes to me with a file and says, we don't like how this file is implemented. How could we make it better? And then, coming up with ways to do that. So that tends to be more of the work I'm doing now. And it's good because a lot of it is related to the courses I'm building. So I just advised one client on, what does it look like to have a reproducible build environment with a standard build interface? How do I take advantage of that with a CI system? And these are all topics that, we're developing for our automated software quality enforcement course. So a lot of it is, it helps me test out some of these concepts and, see how they hold up in the field. It's not just like I've made up a bunch of ideas in my head and put them on a course for people to learn and try themselves. So for that reason, I don't think I'll ever give up the consulting because it's good to have some way to test all these ideas out.
The designing embedded software for change, what's that one going to be like?
So that course goes through, it's a mix of theory and coding, I would say. So there's the theory of why does it matter that we design our systems for change? And, what are some fundamental design principles that we can use when approaching systems that we want to design for change. And those are topics like loose coupling, separation of concerns, information hiding, and the open close principle. And then, okay, great, we have this theory. You need to apply that to a system somehow. So there's some system level strategies for approaching a system to make it changeable. And then each of those strategies I've mapped to specific coding techniques. Some of them are the template method and callbacks that we talked about, so showing examples in the code of how I can actually apply these techniques to support change in my system. And on top of that, we're trying to find real world software. I think that this is, part of the problem in my own career and that I've seen in others is, we read a lot of code and we copy a lot of code to do whatever we need to do. And so if the models that you're studying or you're basing your own designs off of, or the code you're copying are poor, you're going to get poor results. And I'm saying poor, at least on the axis of changeability. So I'm trying to identify what are real world projects that use these techniques that you can look at and see how they actually support whatever, aspect of change they need to support. Showing, and we're also going to, I have some demonstrations I've put together showing, again, okay, I've got this driver that was written for the Arduino SDK. How can I refactor, the implementation just a little bit to make it so now that could be used in any framework I want instead of just on the Arduino?
I'm back to where do you find the time?
A little bit of progress every day adds up. That's all I can say.
What other design patterns do you think are important for embedded software engineers to know?
So state machines have been mentioned. I'm continually surprised, I think, based on how fundamental state machines are to my own work, to find that it's not the case in a lot of the projects I've worked on and teams I've consulted with. I think state machines can clean up a lot of code if you can think about structuring your code in that way. Just
moving to event-driven systems.
That's another
which
thing.
Comes with state machines, but it's just so much easier to think about. And since the topic has changed, that's one of the things that's changed in my development is starting out with a very choose-your-own-adventure approach to software development, where just lots of if-then-else's and functions and things, and just kind of, I wrote very bad code when I was first starting out, to where I hope I am now, which is okay, what are the main actors? How do they need to communicate? What are the things that happen and how are those conveyed to each other? And it ends up in, lots of event loops and state machines and things that I think are pretty readable.
And how do you delete code and how do you delete shared state
or
so
add
only
code?
Buddy
How do I extend functionality? State machines make that quite easy too.
I tend to realize that the code I wrote initially was 90% deletable if I could just replace it with a state machine or something.
Yes.
Not more clever, but something more canonical.
You have a panel. You've done one panel discussion with Memfault, I think it was in April, and you have another one coming up, right?
Yep, that will be at the end of August, the 28th.
And what's the topic on the first one was scaling embedded systems, right?
Sorry, the 25th. Man, okay. I'm not doing good with all my memorization of facts. The first one was on device metrics and how we can use metric collection in the field to help our debugging and, well, I guess all sorts of, prioritization efforts. How do you figure out what features to develop next? Things like that using metrics collected from the field. And then this upcoming panel, we're going to be discussing more generally, how do you debug devices once they've gone out into production?
Cool. And people can sign up for that. We'll have a link, I think.
We'll have a link in the show notes. We'll have a collection of links in show notes.
Collection of links.
I have a bunch of tabs open, so I'll be copying those over before we close them all.
I have one more design pattern that came to mind.
Oh, sure.
Okay.
Communicating through queues.
Yes.
It's like it ties again into states and events, but just more generally, sending data through queues instead of directly passing data between components it's a great way for decoupling things, and for, you can isolate stuff to test. It doesn't matter what's at the other end of the queue as long as you have a standard definition of the data that both modules are using. That's been something that's really helped a lot of my designs.
And it's easier to instrument. I mean, you said you can put something on the other end, but you can also instrument it, transmit and receive everywhere. So I this happened and this guy didn't get it, you can sort of do that with calling functions directly, but it's very messy, and you don't have these central, kind of everything funnels into a central receive. So it's much easier to say, oh, I received this message, and just have a little debug printf that says, got this event.
I totally agree with you about...
I totally agree, but...
the queues, because I've seen that it does make things better. But as I'm on the Wikipedia list of software design patterns, there's no queues here.
Well, there's no design pattern board.
Well, that's the thing, is I feel like I don't know all of these patterns as well as I want to. And many of the things that we do commonly aren't even on here. So design patterns are broken. Let's just give up. No, wait, that's not what I meant to take away from that. I don't know what I meant to take away with. Oh, I guess, Phillip, could you fix that for us?
I will try. I have my own design pattern catalog, so I'm working on it.
Huh, that would be kind of interesting. You mentioned design patterns in embedded C, which is up here somewhere. Design Patterns for Embedded Systems in C by Bruce Powell Douglas. Maybe that's where I should be looking instead of Wikipedia.
Yeah, we know that Wikipedia is always 100% factually correct, and there are no political motivations or, people trying to claim territory on Wikipedia. That never happens.
Well, the software design patterns page seems fairly straightforward.
You can go in there and add queues.
I was going to say add queues, see what happens. I consider message queues and event queues to be a design pattern. But maybe, that I could see message queues being under a message passing design pattern, right?
It would be called the loosely coupled aardvark or something.
Yeah.
Maybe that's what we need, more memorable names.
Yeah.
Yes, I think so. Speaking of Aardvarks, you mentioned the Aardvark tool.
Oh, wow. Nice.
And I, like I said, I have a lot of tabs up. Could you explain it? I hadn't come across it before.
So I discovered them through their USB debug adapter, which is excellent if anybody's working on a USB device and you really need to do analysis of the messages that are going over the bus. But this device is a USB to SPI, I2C, and GPIO, debug adapter. So they have a little GUI program that you can use to talk to devices and, send raw SPI or I2C commands and see what response comes back. But they also provide an API that you can use. I think you also need libUSB, but so you can programmatically work with the adapter. And so I have for my standard SPI and I2C interfaces, I have a Aardvark driver, and I have SPI and I2C interfaces that use that Aardvark driver to talk to the device. And I can control any SPI or I2C device, chip select lines can work because you can do SPI plus GPIO. So it's a pretty powerful tool for one, debugging those devices if it's not working in your system and you want to just talk to the raw device itself to make sure things are like whether you have a fundamental flaw in your understanding or whether there's something else going on. But also, for developing devices without having like a full board in-house. And so that's been a real beneficial practice in my career.
Have you used the Bus Pirate?
I have not. Should I?
I don't know. How you describe it is largely how I would describe the Bus Pirate, but it's an order of magnitude less in price. And so I think there must be some qualitative difference.
Quite as sophisticated.
No, you're definitely kind of bashing at it, but you can make scripts.
Yeah.
I don't think that like you need to necessarily use an Aardvark. I've done this same thing in the past using an FTDI chip. So it's, I wouldn't recommend that necessarily. It's a little more painful than using, an API that somebody else manages for you. But yeah, you can generally use any number of adapters for this. And I think I have a couple of little, China design boards that, I've used from time to time. For example, I wouldn't travel to China with my Aardvark. I usually took a little multi-protocol board with me that I could do JTAG, SWD, SPI, I2C, GPIO controls, all sorts of stuff.
Now for bringing up a new I2C or SPI device that I wanted to just talk to it, I would seriously consider a MicroPython board. It's just so easy to use. And you can really, you can use it both to do the communication and to monitor the lines. So you get both logic analyzing and communication. I don't know. I haven't tried it yet, but I've been thinking a lot about it. Well, Phillip, we have gotten off whatever the topic was. Clearly, we are not in a rut because we went all over the road. So do you have any thoughts you'd like to leave us with?
Check out our website if you like this kind of conversation. I explore all of these ideas in great depth, much deeper than you can get to in a live conversation without code, right? Like it's hard to conceptualize some of this stuff without code. So if you want to learn more about this stuff, check out our website, look at our course list, become a member, check out some of the great members-only content we have in the Field Atlas, and you can always contact me if you have any questions, and I'll point you to the right stuff, if I know.
Our guest has been Phillip Johnston of Embedded Artistry. There will be many links in the show notes, but if you just search for Embedded Artistry, you can get to his site.
Thanks, Phillip. It's good to talk to you again.
Thanks for having me. Talk soon.
Thank you to Christopher for producing and co-hosting. Thank you to our Patreon listener Slack group for some ideas about how they have changed over their careers. And of course, thank you for listening. You can always contact us at show@embedded.fm or hit the contact link on Embedded FM. And now a quote to leave you with from Maya Angelou. I wonder if I've used this one before. Anyway, from Maya Angelou. We delight in the beauty of the butterfly, but rarely admit the changes it has gone through to achieve that beauty.